Okay, here we go, partway into the lesson. Welcome, online people who happen to be watching this potentially. There's what we did. Here's where we are. 8.2. I'm talking to all those people that aren't in the room, which is one person. Well, a couple of people that are writing the test. Anyhow, suppose you and 4 friends race to line up at a ticket booth. The number of ways the 5 of you can be arranged in a line, well, this we could think fundamental counting principle, as we did yesterday. So we have who's going to be in the front, and then all the way to who's going to be at the back of the line. And what are our options? Well, assuming it's random, any of the 5 of you could be at the front of the line, and then any of the 4 left over, 3 and 2 and 1, which is 5 factorial. So whenever we have a certain number of objects, we'll call them, in this case it's people, and we're looking at how many ways to arrange all of them, we just take how many there are, factorial, there we go, ta-da, and we get 120. So a lot of what we do with permutations can be done just using the fundamental counting principle that we looked at in yesterday's class. But we need to understand the factorial notation because it could show up in multiple choice, numerical response, and sometimes it's just a little more efficient for showing our work. So to understand factorials a little bit more, we can look at number 3 here. And we want to reduce this algebraically. Well, more numerically, we don't have any variables, so it's not actually algebra. 7 factorial is 7 times 6, 5, 4, 3, 2, 1. 3 factorial, 3 times 2 times 1. Ooh, isn't this exciting? What cancels out? Oh, this and that. But the point of this question is that we can actually abbreviate this. What I could do is I could say that this 7 factorial over 3 factorial is 7 times 6 times 5 times 4 times 3. But notice down here I had a 3 factorial in the denominator. And I could summarize that 3 times 2 times 1 as a 3 factorial. So rather than writing out the full expansion, I can go as far as I need to until I see that, oh, I have a 3 times 2 times 1, 3 factorial, and a common factor there. So notice this 7, 6, 5, 4, none of those have the factorial. It's only the 3 that has the factorial because that's showing that this pattern continues. So then we could cancel those out, and we get the 7 times 6 times 5 times 4. And this is reduced algebraically. We could evaluate, but we'll just stop there. So, if we were working with variables, but first we have a question. Mm-hmm. If I was evaluating it? If I was evaluating, I'd just multiply it out. Yep. But the reason for doing that is because sometimes we don't know what we're taking the factorial of, as in, what if I have n factorial over n minus 3 factorial? Can I reduce this? Well, I know that n factorial is n times 1 less than n times 2 less than n times 3 less than n, and it keeps going. But I can stop here because I get to the n minus 3 factorial. So everything else gets summarized with the factorial. And in the denominator, I had an n minus 3 factorial. So now I can see that all the rest of it is part of a common factor. So we could cancel out this and that, and we're left with n times n minus 1 times n minus 2. And depending on the question, we may or may not want to expand. For now, we'll just leave this one here. but we can see how what we did numerically up here with the 7 factorial over 3 factorial, we're doing the same thing here with the n factorial over n minus 3 factorial. So, quick tip. Most of the time, it'll be set up so that the numerator is the bigger value. So n has to be bigger than n minus 3. But that's not always the case. So what I would always do is I'd look to see which one is bigger, and that's the one I would start expanding. So if I had n minus 1 factorial over n factorial, I'd say, oh, my denominator is bigger. That's the one that I'll start expanding. So that's going to be n times n minus 1. And then I'd stop and say, oh, that matches my numerator. I'll summarize all the rest of it with the n minus 1 factorial on top. Those cancel, and we get 1 over n. Questions? Yes. Yeah, that's the one that we start expanding. Yep. The one that has the largest value. Yes. We'll get to that once we get to formulas. So unfortunately, I need to update my notes. And so I have 4 questions on this page that are not in your notes. So if you can find some paper somewhere where you can write and work on these. If you have your workbook, there's some blank spaces in your workbook. So we want to see how many ways are there to arrange all the letters in the word locker. So let me imagine a multiple choice question. I don't think I can come up with many options, but we'll see. Let's say we have I ran out of good distractors. Maybe none of them are good distractors. I don't know. A, B, C, D, what do you say? Got some D choices there. Well chosen, you fail. Sorry. Sorry, what? Other than that? What? B, yep, B is a good choice. There we go. Oh, can't see that very well. Let's go green. Yeah, it's just 6 factorial. Now suppose we started introducing some restrictions. So what if the first letter has to be an L, the last letter has to be an R? I should invent some options here. There we go. Let's try those options. So some of my factorials look a little bit not factorial-ish. Okay, let's do a vote. Who votes A? Are we ready to vote? Yeah. Anybody for A? Are we for A? For B? For C? For D? Ooh, lots of people for D. Who wants to present their case? Yes. So if we think, I don't want that color. I could do better than that. 1, 2, 3, 4, 5, 6. So you said the first letter has to be L. So I have how many choices? 1. Oh, 4 choices. And 3, 2, 1. Oh, this one has to be the R. So I have only one choice. Yeah, so again, as we mentioned yesterday, start with the positions that have the most restrictions. So we want to look at probably those two first. We only have one choice for the first position, only one for the last position, which leaves us with 4 factorial for arranging those middle 4 letters. Yep. Well, let's look at the next question. Suppose L and R have to be the ends. Then what happens? Maybe we can reuse these options. So is any of these correct? Yes. Which one? C? All those in favor of C? We're not quite unanimous. Who would explain why C? They're up. So this is L or R, and this is L or R. One of them's at one end, so I pick one for the first end, and I only have one choice for the other end. And then what happened? Which would give us the 4 factorial times the 2 factorial. Taryn. If we look at this 2 times 1, if I put them together, it would be a 2 factorial. So what was your reasoning? Okay. And that's where this question wasn't as clear as it could have been. So the intent for the question was that one end has the L, one end has the R. What you did was you said you put them both at one end. If that was the case, then that wouldn't quite be the right answer. So suppose we change this question. So L and R have to be together at one end. Then what would we do? Yes. Yeah, so either we have L and R at the beginning or L and R at the end, in which case we'd have 2 times 1 here or 2 times 1 there. And then arranging everything else would be 4 times 3 times 2 times 1, 4 times 3 times 2 times 1. So then it would be this number doubled, right? Because it's the same calculation happening 2 times, so it could be times 2. Take note though, 2 times 2 factorial is not 4 factorial, right? So the order we're multiplying things matters. This is just a 2 times 1. 2 times 1 times 2 is actually equal to 4. It's not equal to 4 factorial. So make sure you're being careful with order of operations is really what this comes down to. Yes? No. Because what you've done, this or means I'm adding. So I have 2 factorial times 4 factorial plus 4 factorial times 2 factorial. And since they're both the same, I have this calculation 2 times. If you added them, it would work. Yeah. Good with that one? Well, one more. So the intention, again, this isn't super clear. Say C and K must be in the center. It means there are 2 other letters to the right and 2 to the left. So you can't have 1 and then CK and then 3 letters. So they have to be right in the middle. It just says they're in the center, so it doesn't give us the order. Let's pretend this is numerical response, and so we want a number for the answer. I did say numerical response, but I'm going to give you some answers. So hopefully you have one of those. Okay. Given these four options, anybody say 8? Nobody for 8? 16? 24? 48? Lots of 48s. Tell me how you did it. Yes, 5s. Shh, can you hold on a second? Excuse me. Can we not talk while 5s is explaining here? Thank you. Okay, go ahead again. You're talking about the middle ones, right? Okay. So we have choice of 2 because this is C and K. Okay. Yeah, because any of the 4 can be there, and then 3, and then 2, and then 1. So even though they're separated, we still have that 4, 3, 2, 1 pattern happening. Yes. Because I can have either the C or the K in this first position, but I don't know which. So I have 2 choices. I'll pick one and put it there. Then I have one of these 2 letters left over. Yes. Well, we haven't done permutations in factorials. It could be 4 factorial times 2 factorial. Yep. Okay. Let's go another level of difficulty. We have the 5 letters in the word vowel. If the O and the E must be together, how many different arrangements can we get? So we'll look at 2 different ways that we could do this. And again, as I mentioned before, whenever you have 2 or more ways to do something, it's great because you can do it one way, you can check it a different way. So, but having said that, as long as you understand at least one of these ways, then you're good. So the first option we'll look at, we start with arranging the consonants. There are 3 consonants in my word, and so I can choose to arrange them. I have any of the 3, the V, W, L can be first, and then 2, and then 1, which gives me 3 factorial or 6. And then I could choose a location where I'm going to put my vowels. So I could put both the vowels in front of the 3 consonants, or after the first one, after the second one, or at the end. So I have 4 choices. It's not 4 factorial, because I'm not arranging all of these. I'm just choosing one of these places where I'm going to stick that pair of vowels. So I have 4 choices. I'm not quite done the question, because even though I have my vowels placed in between my consonants, I don't know which vowel comes first and which is second. So I still need to consider arranging the vowels, which is a 2 times 1 or 2 factorial. I'm doing all three of these things, right? So I'm arranging my consonants, and I'm choosing a vowel location, and I'm arranging my vowels, and means I'll multiply. 3 factorial is 6, times 4 is 24, times 2 factorial, 48. Different arrangements of those 5 letters if the O and the E are together. Any questions with that method? Nope. Next method. So same situation, we have those 5 letters in the word vowel. First of all, we'll consider the vowels as a single group, which means we have 4 groups to arrange. We have the 3 consonants plus the vowel group. So we're arranging those 4 things. So we're going to arrange those groups, which will be 4 factorial. And within that vowel group, I still need to arrange those 2 vowels. So that'll be 2 factorial in their group. 4 factorial is 24 times 2, 48 again. So you notice as we look at the numbers, this 3 factorial times 4 is the same as 4 factorial. So the numbers are all looking the same, it's just a different thought process to get to our answer. Questions? No. Because in this first option, I'm not arranging 4 things, I'm just selecting from 4 choices. Kind of like yesterday when we had the example of me with 7 pairs of pants and 4 shirts. I just did 4 times 7 because that's how many things I was choosing from. I was choosing 1 out of those. Just like here, I'm choosing 1 out of these 4 options. So it's just 4 possibilities. Justin. Yeah. Option 2 starts by grouping the vowels together into a single group since they have to be next to each other. And then I think I have 4 groups to arrange. So each consonant is its own group. The vowels together is a group. So arranging those 4 groups is 4 factorial. Then I just need to arrange the vowels inside their group, and then I'm done the question. Yes. Why is this 2? Because there are 2 vowels, O and E. So I have O or E. So I have 2 choices, and then I have 1 choice for the next one. Yep. Yes. Well, I have 4 spaces, essentially. So when I think of my 4 spaces, I'm choosing to put either an L or a W or a V or my vowel combination in each of those 4 spaces. Suppose with number 5, the vowels must not be together. And again, we'll look at 2 ways we could do this. The first way, which is the easiest way for this question, is to say, well, what if I look at all of the possible arrangements I can get and then subtract out what I don't want? And what I don't want is vowels together. So, all of the possible arrangements, I have 5 letters, so it's 5 factorial. How many of those have the vowels together? Well, we just calculated that. That was 48. Five factorial is 120 minus 48. 72 arrangements don't have the vowels together. So this works if we have a word like vowels where we have 2 vowels. Where this wouldn't work, and we won't get into an example like this, would be if I had a word like I just can't think of the word. Let's say what if we said the consonants can't be together, but we have the same word? The consonants not being together, we'd need some clarification. Does that mean all 3 of the consonants can't be together, or any pair of consonants can't be together? So that would make it more complex if we have more than 2 things either grouped or that can't be grouped together. That's just a variation I'll mention. Perhaps I shouldn't have, given how little time we have left. But let's look at the other way we could do this. This would be similar to our first method for number 4. We could arrange all the consonants and then choose 2 locations to put the vowels in. So I have 3 consonants. And arranging those will be 3 times 2 times 1. And then I need 2 locations for vowels. The problem is, how many pairs of locations can I get? So that's where this method is going to take a little more time, because I could look at this and say, well, this is 1 pair of locations. That would be 2. That would be 3 possibilities. This would be a 4th possibility, a 5th possibility, 6 possibilities. So it takes a little more time for us to count out. Later in the chapter, we're going to learn a faster way to do something like that. For now, we're stuck with having to count out the different possibilities where we could put the 2 vowels. So that would give me 3 times 2 times 1. I'm going to move this over there. So arranging the consonants is the 3 factorial. Choosing 2 locations, there's 6 possibilities that we just explored. And I need to arrange the vowels. That would be a 2 factorial. So 3 times 2 times 1 is 6, times 6 is 36, times 2 is 72. So we get the same answer. Okay, 5 minutes left. Got to fly to get through this next little bit, and we'll see how far we get. This is called Check Your Understanding, but we won't do it that way. 8 students, 3 will present today. How many different ways can we arrange? Well, I have 1, 2, 3 presentations that are going to happen. any of the 8 people can go first. And then any of the 7 and any of the 6. So fundamental counting principle looks like that. But because we're learning factorials, sometimes with math we just like to play with numbers a little bit. So let me play with the numbers here and say, suppose I wanted to change this 8 times 7 times 6 into a factorial. Well, I would need a times 5 times 4 times 3 times 2 times 1. But if I wanted to actually equal what I have in black, I have to divide all that out as well, which gives me, just abbreviated, it's 5 factorial. Which means my answer to this question looks like 8 factorial over 5 factorial. Well, is this pure entertainment? Well, no. Of these 8 students, how many students am I not arranging? You can do this. There are 8 students. 3 are presenting today. How many are not presenting? 5. That's where this denominator comes from. My mom? Hi, Mom. Oh, no, okay. Yesterday we said and means multiply. So guess what divide means? It would be like and not or but not. So this is saying I'm going to arrange all 8 of my people, but I'm not going to arrange 5 of them. So that's why they get divided out, because that's what I'm not arranging. That leads us up to permutation notation. NPR. It's not National Public Radio, as in the States. It is, from n objects, I'm going to choose and arrange r of them, or I'm going to permute r of them. So what this means, well, let's look back at the question we just had. Here I have 8 students. Of these 8, I'm going to permute 3 of them, which means I'm choosing them and I'm arranging them in a particular order. We just saw that 8p3 is equal to 8 factorial over 5 factorial. Where did that 5 factorial come from? Well, that was 8 minus the 3 that we were arranging. So in our formula up here, this would be n factorial over n minus r factorial. And again, what it says in terms of the words, n factorial is all the objects I have. I choose and arrange all of them. N minus r, well, I'm arranging r of them, so n minus r is how many I'm not arranging. So that's what goes in the denominator. And that's as far as we're going to get, except undo these blanks. And means multiply, and not, or but not, means it will divide. Number 8 is where we'll have to start tomorrow. Pardon me? Yeah, you can do most of the stuff in the homework. If you have a question like number 8, then skip past it. Goodbye, people in Videoland.